This is the solution to WEX 18.2. Okay. A sketch of the story. A sketch of the story is that we've got an axis here, and F is, you can think of F as the output, and S as the input. The number of sunspots is the input, and the output is the number of four-leaf clovers. Then we have 2 points. So at 20 and 1600, so we have S1, F1 at 20 and 1600. And we have S2, F2 at another point, 11, 12, 67. We can plot those two. So this point is further to the left and also further down. Further left because the horizontal coordinate is less, 11 less than 20, and further down because the vertical coordinate 12, 6, 7 is less than 1600. Okay, so something like this. So that's the point 11, 12, 6, 7. And a little bit to the right and up is the other point, 20 and 1600. And we want the equation of the line that goes through those 2 points. Okay. So that's what part A is asking. So part A is saying find the equation of the red line. All right. Well, the change in S, that'd be 20 minus 11, which is 9, and the change in F, that'd be 1600 minus 1, 2, 6, 7, which is what, 333? So the slope would be delta F divided by delta S, which is 333 divided by 9. Let's see, do I trust myself to do it in my head? Not really. Well, maybe. How many 9s can I take away from 33? 3 9s. And then there'd be 63 left over, so there should be 37. 37? Let me check that. I'm going to need the calculator anyhow. 333 over 9. 37. Okay, so there's the point there, and I'll use S1 F1 equal 20 1600. Now I could have used the other point to using the point slope formula, but because there's so many zeros there, it seems to me that's the easier point to deal with. So it would be F output, right? F minus F1 is equal to M multiplied by S minus S1. Okay. So this would be F minus 1600 is equal to 37 multiplied by S minus 20. So F minus 1600 is 37 S minus whoops, no, 30, no, 20 multiplied by 20. 740. I guess I could have done that in my head. So F would be 37 S, and then we'll add 1600 to that. Whoops. So plus 860. So find a linear model. So that's the answer to part A. Well, that's the linear model anyway. The work really is the answer to part A. Verify your model. Okay. So for part B, we've got the model there, and the question is, do the other points, do both points satisfy that equation? Okay, so this is where we'll do our verification. So verify using the first point, 20 1600. So the equation would read 1600 equal 37 multiplied by 20 plus 860. So 1600 is, well, that'd be 740 plus 860. So 1600 equals 1600. Good. That's true. And we'll check the other point. 11 and 12, 6, 7. So in this case, the equation reads 12, 6, 7 equal 37 multiplied by 11 plus 860. So 12, 6, 7. Well, 37 times 11 is 407 plus 860. So add 860 to that is 1267. Which is also true. Okay, so we must have the correct model. Finally, part C, translating that request, determine the number of four-leaf clovers per acre when the number of sunspots is 15. It's saying find F when S is 15. right. So f would be 37 multiplied by 15, add 860, so f would be 15. So I'll double check my arithmetic. Okay, arithmetic looks good on the calculator. Now, I want to consider, I want to sort of check, you know, is this answer reasonable? So check for reasonableness. Reasonableness. I'm not even sure that's a word. Reasonableness. And I'll do that on the plot. Well, so we were given a point where there was 11 sunspots in the statement of the exercise, and we were given a point where there were 20 sunspots in the statement of the exercise. And for part C, we're asking about 15 sunspots. So that's about right here-ish. 15 sunspots. Okay. So furthermore, we know that when there's 11 sunspots, there's about 1,200 four-leaf clovers per acre. So there's 12, 6, 7 in that case, and when there's 20 sunspots, there's 1,600, so 1,600 here. And well, when there's 15 sunspots, just as a rough sketch, that's pointing where that's pointing to the value of the four-leaf clovers per acre. So could that reasonably 14, 15? Could that be F? Yeah. So you know, we have 12, 6, 7 less than 14, 15 less than 1,600. So, you know, that's great. If an arithmetic error had been made, and you know, so I'll just say parenthetically, an answer like f equal, I don't know, something a lot less than 1267, like f equal 238 would be way too small. So it would be unreasonably small. So such an answer, such a response not only would be incorrect because it's not 14, 15, but it would be incorrect in such a way that that response would be nonsense.